Hi, in this lesson we are going to talk about two concepts that are super important in every graph that you're ever going to draw or ever going to read, and they are called domain and range. Now, domain and range is always said like domain and range. We never say it backwards. Range and domain just doesn't sound the same. And this is nice because it's in alphabetical order. D comes before R in the alphabet. And this is good because domain represents everything that the X variables are doing on a graph. And the range is going to talk about what the Y variables are doing. So domain and range's job is to tell you what X values and what Y values are allowed. It's a pretty simple job. Remember, it goes in order. Domain is X, range is Y. D comes before R, X comes before Y. Now, there's three main ways that we like to look at domain and range, and I'm going to show you how those work. This is all about notation, and notation is the way we write things out in math. It's like the correct way to do things, having some etiquette. So let's come up with a graph first. Let's say we're talking about how much money you made selling lemonade. And let's say you made $2 because you sold 1 cup of delicious lemonade. And then you sold another cup and you made $4. And then, I don't know, you sold a few more. And let's say you made $7 selling 5 cups of lemonade. So the amount of money you made today, was kind of represented by this graph. So it's really obvious on this graph that there's only a certain portion of the graph that's being used by your numbers. And it's this little corner right here. So if we look really closely, our graph only goes in this certain area. So we're going to represent that area by talking about its domain and range. The most common way to talk about domain and range is using inequalities. And I bet you guys remember what inequalities are. They're those little arrow-looking symbols. And if we talk about greater than or less than, and then we also will draw a line under it if we want to represent greater than or equal to, or less than or equal to. So we can use those in domain and range. So for example, if we look at this graph, what is the highest value of X that we use in this graph? Well, it's 7. So that means that if I was going to talk about the domain of this graph as an inequality, let me write that out for you. This is the inequality way of showing the domain and range. The domain would mean that 7 is the largest number and that all of the x's have to be less than or equal to 7. But look carefully, what's the smallest x value we've got? Well, that's going to be 0. So we know that the domain, the x also has to be greater than 0. So I'm going to add that 0 in here and write myself one inequality that says that x is greater than 0 and less than 7. So this reads that x is greater than or equal to 0 and x is less than or equal to 7. Now the range is the exact same thing, except I'm going to use the y values for that. And if you look carefully at these y values, what's the lowest y we have on the graph? Well, it's 0 again. And on this axis, our highest y value is 5. So for the range, I'm going to rewrite it in the same way. I'm going to write down my y, and I'm going to write out that y is in fact greater than or equal to 0, and y is less than or equal to 5. So that's how I would write this as an inequality. The other type of notation that we use a lot with domain and range is called interval notation. So interval notation is a little bit different. I like to think of it as being a little more formal, if you will. In interval notation, we're going to use brackets. And there's two types of brackets. There's square brackets and there's rounded brackets. And they each represent something different. The square bracket represents numbers that are included. So similar to an inequality, when we had greater than or equal to, if it's equal to, then it is included. The rounded brackets mean the number is not included. So it's been excluded. So for example, with this, our domain and range in this case would be a little bit different. Our domain and interval, since 0 and 7 were included because they were part of it, we would use our square brackets and we would just write 0, 7 bracket. And that shows that 0 is our starting point and 7 is our end point. And the range would be the same as we had before, except this would be 0, 5 with a square bracket. Again, we're choosing square brackets because those numbers are included. They were part of it. Interval notation looks a lot like a coordinate, but it's not. And the reason I know it's not a coordinate is because the question or however you've answered is going to state that it is part of the domain and range. Like I wrote the word domain right next to this, so it won't be mistaken as a coordinate if you were to use the round brackets especially. The other type of notation that we use that's probably the most common, I would say, is what we call set notation. So set notation has an interesting way of being written. So set notation, I'll write that out so you can see what that looks like. Set notation. Set notation uses what we call a brace, and it's this kind of curlicue. Let me draw a better one. It's this kind of curlicue bracket, but it's called a brace. And when we talk about domain, we're going to draw our curlicue brace, and then we're going to write the letter X, and that's telling you that we're talking about X. Then we're going to draw a long line. It needs to be longer than the letter L, so everybody knows that it's a line. And then you're going to tell me what set of numbers your graph is using. So we're going to say that the X here are all real numbers. And real numbers, remember, are your integers, your negatives, your decimals. And we're going to represent real numbers with the capital R. And then you'll notice I drew this funny symbol right here. This symbol is like a mix between a C and an E, and it means is an element of. So what it's basically saying is X is a real number. Right after that, we're going to put a comma, and then you're going to tell me about the limits on the numbers that are available here. So again, we're going to go back to our inequality, and we're going to say, remember that X was bigger than 0 or equal to 0, and that X was also less than or equal to 7. And then we finish it off with another brace. And then we do the same thing for Y. So I'm going to say for the domain, or for the range, I'm going to say we're talking about Y's. I draw my nice long line. Then I'm going to say that Y is also an element of, so that's that funny looking symbol, an element of real numbers. And then we're going to look again and remember that our Y's were in between 0 and 5. So I can come back over here and say that all my Y values were greater than or equal to 0 and less than or equal to 5. And then finish it off with a brace. I have two more quick examples for you. And this graph looks a little bit different. If you'll notice, this graph is just a series of dots. They're not connected together. So this is a discrete graph, right? Because it's not continuous. It's just a series of dots. So the domain in this one looks a little bit different. It's really kind of a combination. We're going to start with the brace, and then we're just going to list the x values that we've used. So you can see that there's a -4, a -2, a 2, and a 6. Those are the only x's that were used. So we're going to just simply list those to show our domain. So -4, -2, 2, and 6. Finish it off with a brace. And then for your range, you're going to list those as well. So if we come up here and look at the y values we used, let's see, you can see there's a point plotted on 1, on 2, and on 3. So then we can list that as well. 1, 2, and 3. So that's how you would handle the domain and range of a discrete graph. Now, what you're going to see most often is going to be a continuous graph that goes on forever. So I've already plotted some points here, but when we connect all of those in a graph and we put arrows on the end, what that means is that graph is going on forever. So in that case, there is no end or beginning to where our x values go. So in that case, we would very simply say that the domain, if we were using set notation, the domain, x is an element of all real numbers. And for the range, y is an element of all real numbers. That's it. There you go.